Hello everyone. In this video, I would be explaining the leetcode problem number 135, the candy problem to you. The difficulty level of this problem is hard. So let's start by first reading the question. There are n children standing in a line. Each child is assigned a rating value given in the integer array ratings. You are giving candies to these children subjected to the following requirements. Each child must have at least one candy. Children with a higher rating get more candies than their neighbors. Return the minimum number of candies you need to have to distribute the candies to the children. Let's look at the examples. Example number 1, we have a rating of 1, 0, and 2, which means child 1 has a rating of 1, child 2 has a rating of 0, and child 3 has a rating of 2. And the expected output is 5. Now let's see how we came to the expected output 5. So, following the first condition, each child must have at least one candy. Here, we would distribute one candy each. So, since there are 3 children, we would be needing at least 3 candies. And now let's look at the second condition. Children with a higher rating get more candies than their neighbors. So, this point says that the child with a higher rating should get more candies than its neighbors. So, let's look at the first child. He has a rating more than its neighbor. So, we should give one extra candy to him. More candy, basically, more candy than the second child. So second child has one candy. So we would be giving two candies to the first one, which is one extra candy. So now the total number of candies that we have are 4. Now let's move to the next child. Next child does not have a rating greater than any of its neighbor. So we'll move ahead. Now child number 3. We'll come to child number 3. Child number 3 has a rating greater than the child 2. So again it should get one more candy than child number 2. So he would be getting 2 candies. The final distribution would be of the candies would be 2 for child 1, 1 for child 2, and again 2 for child 3. So the output would be 2 plus 1 plus 2, 5. Similarly, we would do the same kind of distribution in example number 2. Now let's see how we can solve this problem in JavaScript. So the best way to solve this problem would be through the greedy approach and following a linear distribution from left to right and then from right to left. Okay, so let's see what I have done here to solve this problem. I have initialized a variable and variable n that would have the count of number of children that we have by having the count length of ratings. Then I'm checking if n is equals to 0 or not. If it's 0, then return 0, because if the array is empty, we don't have any children there, and we would just not distribute any chocolates or candies. Now I have taken another array, sweets array, that would contain the number of candy each child would have. Initially, I have created this array of size n and filled it with 1, because each child would have at least one candy as per the description of the question. Now, what I have done is I've created a for loop so that we can go from left to right to compare each children with its previous neighbor, to compare each child with its previous neighbor, and determine if he should get more candies or not. Remember the second rule, children with higher rating should get more candies than its neighbor. Okay, so here I would be comparing each child with the previous neighbor or the left side neighbor. So the for loop starts from the beginning and it goes up to the end, and inside that I have an if condition. If rating at I, if the rating of the ith child is greater than the rating of the uh, is greater than the rating of the previous child, or the child who is on the left side, then what we would be doing is we would increase the sweets count for that person, and we would make it equal to the sweets count of the previous child plus 1. So let's say if the sweets count for the previous child is 1, and uh, he has a rating less than the current child, then we would make the current child sweets count 1 more than the sweets count of previous child. Okay, that is what we are doing here, and this would go till the end. Let's take the example of this one. So the rating is as follows. The rating is like this, and the sweets count is 1 comma 1 comma 1. So after the first iteration, uh, we checked if 0 is great 0 at the second child rating is greater than the first child or not. So in this case it wasn't. Then we went to the next iteration and we found that the third child's rating is greater than its previous neighbor. So we increased the value of number of sweets that the third child would be getting, and we made it 2. Okay, now we went ahead, and for the next one we needed a sweets count, because in this one we would actually be finding the sum of the sweets that we need, and we made the sweets count equal to n sweets at n minus 1. So basically the last child number of sweets he would be getting, we have kept that as the initial value of the sweets count, because in our next iteration of the for loop we would be um, moving from right to left. So the first child's sweets count has been stored here as the initial value. Now for the right to left iteration, we began from the second last child and we would be going to the first child for comparison. And inside this one, we have a if loop, we have an if statement where we are comparing if the ith child's rating is greater than the the ith plus 1 child's rating. If yes, then what we would do is we'll the sweets at ith position, basically the sweet for that child would be the max of sweets at I, or the max of sweets at ith plus 1, and then whatever the value we would get plus 1 to that. So whichever would be more, we would give that much of sweets to this person. And here we are using math.max because we would be having 2 sweets count in certain cases. Let's say if this person has 2 sweets and the person to its left has a higher rating, So already the sweets count has been increased previously. So now we would be needing to increase the sweets count by one more time. So that is why we are using math.max here. Once we come out of this if loop, we would be um, increasing the sweets count by adding the number of sweets at ith position, okay, for that particular child in the loop. And once we come out of this for loop, we'll return the sweets count. So let's try to run this problem, this solution, and both the cases have passed. We In this problem we have to make sure that we don't try to compare both the children, like the left child and the right child at once, because uh, the edge cases we won't be able to find the right number of sweets count. Let's say uh, child one child has two neighbors, and or let's say a child has a left neighbor who has a greater rating, and then again that left neighbor has another left neighbor who again has a greater rating than him. So in such cases there is a high chance that we won't be getting the actual number of sweets, because that is an edge case. The rating, the change in the number of sweets count for one child can affect the change in number of sweets for other children as well. So we have to follow this approach to make sure that our solution is always right. So hope you enjoyed the video and understood how we can solve the candy problem. Thank you.